So we'll be looking at demand, supply, and elasticity. So for any basic business student, you must understand that demand looks at the ability and the willingness of somebody to pay for a product. The statement demand of a product includes three things: the willingness, ability, and the period of time. And so to understand this, I'll use some curves that you need to understand. To start with, demand is downsloping. So a demand curve or a function looks like this, which is given by A minus BQ. The minus just tells you that the slope is going downwards. This is a minus slope. Then supply is upsloping. So when you see a supply function, it looks like that. So it is given by A plus BX or BQ. So when these two curves meet, they meet at a point called equilibrium. Equilibrium is a point where the demand and the supply curve will meet. So as much as possible, the demand function, or the demand, the consumer always wants to go down the price, whereas the supply wants to go up. But unanimously, these two meet at a point which we call equilibrium. This graph here is called the consumer surplus, the area there, and this area here is called the producer surplus. When we add these two, they are called the social welfare or the producer surplus, the total surplus. When you add the consumer surplus and the producer surplus, the total is called the total surplus. So let's do some graphical illustrations. If we had these two curves, one is downsloping, the other is upsloping, and where you're meeting in between here. So here we have 0, here we have 10, here we have 3, here we have 8, and here we have 28. Can somebody identify which one is the consumer surplus and which one is the producer surplus between A and B? Which one is the consumer surplus and which one is the producer surplus between A and B?
A is consumer surplus, B is in producer surplus.
A is the consumer surplus and B is what? Producer surplus. And when you notice quickly, these two curves follow a what? A triangle. And the area of a triangle is given by what? Half times base times height. So I want us to identify the base. I want us to identify the height for area A. What is the base for area A? From here to here.
20.
From here to here, what is the base?
That's
10.
10 and 20. The
About
other side
here
20.
20. That's 28 minus 8 is 20. About here from 28 to 3. What is the height here?
It's 5.
5. So for area A, our base is what? 10. And our height is what? 20. And when we compute that, we're going to get what? 100. For area B, our half base, our base is what? 10. Our height is what? From here to here, it's 5. So when we compute that, we're going to get 50 divided by 2, which is 25. So when we add area A and area B, we call this what? The total surplus, or our social welfare. So 100 plus 25, we get 125. That is how we get to that. Now, how do these curves come about? So I have a very basic way. It's part of your topic to know how to sketch. A demand function looks like that. For instance, you have 100 minus what? 2Q. So you need to learn how to sketch this equation. You put the letters on one side. So here, when the 2 goes this other side, it will add. Then here we're going to remain with what? 100. Then you're going to identify the intercepts. There's an invisible one there. 1 into 100, what we get? We get 100. 2 into 100, what we get? We get a 50. So the P is always found on this axis, and the Q is always found on this axis. So where is it cutting the P? At 100. Where is it cutting the Q? Q is cutting it at 50. So 50 somewhere there. So this is how we sketch. Suppose we had a supply function which looks like this. 10 minus 3Q. What did I say? You put the letters on one side, just ignore the S there. This one will be plus. This is not a supply. It must be a positive gradient. So when it goes inside, you subtract. P minus 3Q is equal to 10. What number is before the P? Is an invisible one. 1 into 10, we have a 10. What number is before the Q? We have a negative 3. Negative 3 into 10, negative 3.33. So let's learn how to sketch this equation. Let us learn how to sketch this equation. So can somebody tell me where will it cut the p-axis? Can somebody tell me where will it cut the q-axis? Anyone?
So Q will be at 10.
3.3.
Sorry, 10 at P at 10.
P at 10, Q at 3.3.
So P will be at 10.
At negative 3.33.
Then Q at negative 3.3. Are we together? So how will the curve look like? The curve will move from here upwards there. All right. So when we combine these two curves, how will they look like? So the supply was starting from 10, and the demand was down sloping from where? From 100. The point where they meet, we said is called what? What is this point called?
Equilibrium.
Equilibrium. So what happens at equilibrium? At equilibrium,
Supply is equal to demand.
okay. So demand is equal to supply, correct. And our demand function, do we remember? Our demand function was given by what? 100 minus 2Q. And our supply, 10 plus 3Q. So let's put them there to calculate it. So 100 minus what? 2Q. And our supply was what? 10 plus 3Q. So what do we do at this point? Evaluate what we do at this point.
We group, we put the like terms together. That will simplify.
Okay. So
100 minus 10.
So like terms there.
3Q plus
100 minus 10. Then here we're going to have 3Q.
3Q plus 2Q.
Plus 2Q. So let's evaluate here. What do we get? 90. And here what do we get? 5Q. All right. So what do we do now? We solve for Q.
Yes.
So what do we do on both sides? We divide by 5. We divide by 5. What do we have? 18. So 18 stands for the equilibrium quantity. So here we put what? 18. All right. So how do we find the equilibrium price? this quantity, you substitute it in any of the price functions. We had two price functions there. There was 100 minus 2Q for the demand, and there was what? 10 plus 3Q. We'll substitute them in both of them to just show you that we are going to get the same answer. But ideally, in the exam, you don't need to do both. So let's start with the supply, 10 plus 3Q. So where there's Q, we put what? 18. So what do we get when you compute?
It's going to be P is equal to 66.
Okay. P is equal to 66, is that correct? So 3 times that one is 54. So 54 plus 10 is 64.
54. 64.
So this will be 64. So our equilibrium will be at 64. Okay. Suppose we put it in there as 18. So 2 times 18 is 36. 36 from 100, we still get 64, it's the same. So there are two triangles here. There's X and Y. Which one is our consumer surplus and which one is our producer surplus between X and Y?
X is consumer and Y is supply.
Okay. X is our consumer surplus and Y is our producer surplus. So let's check now and calculate the consumer surplus. So consumer surplus, who remembers the formula?
It's half base times height.
Half base times height. Okay. So let's identify the base. The base is which one? From here up to here. Okay. The heights we have from here up to here, and also from here up to here. So what is the length of the base? 18, right? 18, because 18 minus 0 is 18. About the height for the consumer surplus from here up to here, what do we have? 36. About from here up to here, 54. All right, together. So
Yes.
half our base is what? 18, and our height is what? 36. So when we compute that, what do we get? 18 times 36 divided by 2. We get 324. Then the producer surplus is also half BH. What is the base for the consumer surplus? It's the same 18, they share it. But what is the height?
54.
54, correct. So 18 times 54 divided by 2, we get 486. Now this 486, when we add it to the 324, collectively will give you what we call the total surplus, which is 810. The other term for the total surplus is called the social welfare. All right. So now I want your participation. We go to an exam type question so that we see how the questions come. So let's go to this question here. We're given question part A and part 2. So we're given the following demand equations. We're asked to calculate the consumer and the equilibrium, quantity, and price. So I want the ladies now to lead us through what do we do. Ladies, we're given this, what do we do? How do we find the equilibrium to start with?
This is the one we first calculate, right? So that
Yes.
after,
Okay. Our statement is what, first of all? What happens at equilibrium?
given the following demand and supply equation, calculate the equilibrium price.
So equilibrium occurs when? When we have an equilibrium?
When demand and supply meet.
Good. Demand is equal to supply. All right.
Mm.
So what is our demand? Ladies, participate. What is our demand function?
Demand is 220 minus 20p.
220 minus 20p. Correct.
Yeah.
Then our supply?
Quantity supply is 20p minus 200.
20p minus 200. All right. Then what do we do?
We collect like 10.
Right. So 20p here. When this one goes inside, what will happen?
To be a positive to add.
Okay. When this one goes inside, what will happen?
To add.
So we're going to have what? 420.
420 is equal to 40.
Then at that point, what do we do? We divide both sides by 40. All right.
Yes.
So what do we have?
10.5.
P is 10.5. So what do we do to the 10.5? To
We
find our
place it
Q?
in the formula, whichever.
Whichever, correct. So here, our Q is equal to 20p minus 200, any of them. So 20p, where there's p, we put 10.5. So what do we have?
20.
So what becomes our
10.
equilibrium?
10.
10. So price equilibrium was 10.5. Quantity equilibrium was what? 10. All right, 2 marks for each of them. Of course, we're not taught to illustrate, but I'll ask the gentlemen to do the illustrations. How do we sketch these graphs? Gentlemen, how do we sketch the graphs?
So you draw the X, I mean the PS lines, the vertical and the horizontal axis.
Okay.
Okay, so for demand function, you take the one which is the demand function, you take the 20 to go to the other side. So it becomes a QD plus 20p is equal to 220.
So you're putting the letters on one side, yes?
Yes, yes.
So what number is here
there,
before?
There is a coefficient 1.
1.
So 1 into 220, it will give us 220. And 20 into 220, it will be 11.
Okay. So cut.
That means the 220 will be on the P, that's price.
Are you
The
sure?
11 is down there. Yes, yes.
You swap them.
Oh, sorry. The P will be 11 and the quantity will be 220.
Excellent. Okay, the ladies, how do we sketch the supply?
Just the same like you were doing on the.
Any other lady to help us do the supply? So you put the letters on one side, lead us through step by step.
Yes.
Yeah, so it's going to be
Q.
QS
Mm-hmm.
minus
QS
QE
minus 20P
minus 20P
20p.
equals to 400.
Mm-hmm.
Then Q has got the
The coefficient of Q is what? 1.
1.
So 1 into negative 200 is negative 200. Negative 20 into negative 200, positive 10.
Negative.
All right. So meaning it will cut the P at positive 10, and it's coming from negative what? Negative side here. Although we don't consider the negatives, just for the sake of plotting. All right, so we're interested in this part here, which is what? Our 10. And we calculated the equilibrium price and quantity. What was the equilibrium quantity? Price was 10.5, quantity 10. So 10.5, and our quantity was 10. So between W and Z, which one is a consumer surplus and which one is a producer surplus?
W consumer, Z producer.
So our W is a consumer surplus. Who remembers the formula for the consumer surplus? Half BH. And what is our base in this case?
Basic.
What is our base?
10.
And our height?
Nataka somo na umwana mwebanta.
What is our height?
0.5.
Our height is the difference here, which is 0.5, and also the difference here, which is 0.5. So here we're going to have 0.5. So our answer will be 2.5 there. Then the producer surplus here is Z in this case. So our producer surplus, half BH, our base is still shared as 10, and our height is also 0.5. So we're going to get 2.5 as our producer surplus. And when we add them, we get 5.0, which is called our total surplus,
Social, yeah.
or the social welfare. Now, plotting is paramount in your course because you need to understand a number of things. So we have learned how to plot linear equations. Now you need to also learn how to plot quadratic equations. So I'll get you back to your grade 12. So whenever you have an equation which is like this, okay, or an equation which is like this, it is a quadratic equation. It cuts the x-axis at 2 points, here and here. where we can go this 2, 4. It may also cut it at 2 points, -1 and -6 here and there. So this one has a minimum point. It's called a minima. This one has a maximum point. All right. Now, before we identify the minimum and the maximum point, we need to know what a quadratic equation looks like. So a quadratic equation has the following format. It has 3 coefficients, or 2 coefficients and a constant. So to find the value of q, or the value of x, we have a general formula which we use, which is a little bit ugly, but you just need to master it. So this is our quadratic equation, the general equation, which looks like that. So to start with, you need to learn how to identify the coefficients a, b, and c. So suppose I gave you these 3 equations here. Equation A is 2x squared plus 4x minus 6 is equal to 0. And we have 12 minus x squared plus 11 is equal to 0. Then here we have 3x squared minus, and here minus 4. Then here we have an x there. So I need you to help me identify equation 1 here. What is our a, b, and c in this equation there? Let's identify a, let's identify b, and let's identify our c.
A is 2x squared.
Okay. Our a is 2, right? Our a is 2 because it has the square here. So this is our a, which is 2. And our b?
Our B is 4.
Our b is 4. And our c? C is negative what?
6.
Negative 6. How about part b? What is our a?
Our A is 1.
Negative 1. Be precise, not 1.
Negative 1.
Our b?
There's no B.
Excellent. There is no b, yes. Right? How about if I put 11x there? Which one is our b?
Positive 11.
Positive 11. And our c?
Positive 4.
Positive 12, correct. How about part c? Which one is our a?
Positive 3. Positive 3.
Positive 3. Our b?
Positive 1.
Positive 1. And our c?
Negative 4.
Negative 4, correct. So I'm glad you're able to identify which ones are A, which ones are B, and which ones are C. So using question number A, we want to identify the 2 points. Now, so identifying these 2 points which cut the axis, so our B, we identify it is 4. So where there is B, we put 4. The negative is already part of the formula. Then B squared, so put 4 squared minus 4AC. Our A is 2. Our C is minus 6. Then over 2A, our A is 2. So here we have minus 4 plus minus, then 4 squared is 16. Then you multiply these 3, where 4 times 2 is 8. 8 times 6 is what? 48. So we put the 48 there. All right. Then 2a. So this is 2 times 2, which is 4. What is 16 plus 48? 64. And the square root of 64, what do we get? 8. So here we have 4 plus minus 8 over 4. So we have minus 4 plus minus 8 over what? 4. So the first value of x, you can go to the subtraction if you want. Minus 4 minus 8 over 4. So here we have minus 12 over 4, which is minus 3. Then here again, the second value of x, we can now use a plus. Minus 4 plus 8 over 4. Here we're going to get 4 over 4, which is equal to 1. So the two values of x, there is a negative 3 and there is what? Positive 1. There's negative 3 and there's positive 1. So if we are going to sketch this, it will come out like this here. It will cut at negative 3 and it will cut here at positive 1. So this is our y and this is our x. So this is how we sketch our quadratic equations. It's very important that you understand how to do this sketching. But how did I know that this will look like that? Because somebody would suggest to say, suppose I can give an impression that it will move like this to cut at negative what? Negative 3 and here at positive 1. How do we know that? I differentiated twice. I'll teach you differentiation. All right, so this is how we sketched this one here. So I want us to help me sketch this equation. Suppose we are told that y is equal to 4x squared plus 2x. How do we sketch this equation? Y is equal to 4x squared plus 2x is equal to 6. Let's identify what is our a. So we let y be 0 for us to make it a quadratic equation. It only makes sense if it's equal to 0 there. So let's identify what is our a, what is our b, and what is our c together. What is our a?
4. Negative 4.
A is equal to 4. What is our b?
Positive 2.
And what is our c?
Negative 6.
Negative 6, correct. Then can somebody give us a general formula to find x? What is the general formula?
Negative b
Mm-hmm.
plus or minus square root of b squared
Mm-hmm.
minus 4ac
Mm-hmm.
over 2a.
Okay, excellent. So let's substitute. What do we put here?
2x
Mm-hmm.
negative 4 squared
Mm-hmm.
or
Sir, there on the first one, like as in negative 4, shouldn't be negative 2.
B is 2, right? So it's negative 2. Correct. Uh-huh.
over 2 4.
Can you come and put back the thing on the head?
All right, so what do we have here?
Negative 2b, negative 2 plus or minus 4
So what do we have there? So we have the square root of 100 is what? 10. So x1, we start with the subtraction. Minus 2 minus 10 over 8. In the second one, we add minus 2 plus 10 over 8. So here we're going to have 1. Here we're going to have 12 divided by 8, which is negative 1.5. So this is how we find the two values of x. Right. So you really need to practice and practice hard. Now, before I go quickly, you also need to learn briefly how to differentiate. For you to understand the way the curves will look like, we need to know how to differentiate. Differentiation, really, we're only going to learn one rule, which is called the power rule. The power rule is given by the formula dy over dx. Then we're going to have n(a)x n minus 1. What does this mean? It means if you have an equation called 5x to the power 4, this is called dy over dx. We're going to multiply the 5 times the 4 to get a 20. Then you subtract 1 from the 4 to get a 3. Let's try again. If you have y is equal to 10 to the power 3, who wants to try? What will this one be called? It will be called dy over dx. Why? Because this side there's y and this side there's x. So when differentiate, what do we get? What are we doing? According to this rule, you multiply the power times the coefficient and subtract 1 from the power. So which numbers are we multiplying here?
20 by 3.
10 times 3, which is what? 30. Then what are we doing here?
We're subtracting 1.
With the power what? The power 2. All right. Suppose there was p here. We have 10q to the power 3 minus 4q squared plus 5q minus 6. Because the letter which is this side is p, we're going to call this dp over dq. dp over dq. Right? We'll multiply this one by that one. We get a what? A 30. When we subtract 1 from there, we're going to have a 2. We multiply it 4 times 2, it's negative 8. When we subtract 1 from the 2, it will be an invisible 1. Here is already an invisible 1. 1 times 5 is 5. When we subtract 1 from the 1 to be 0, so the q will come out. This one has no q at all, so it will drop out as a constant. Another one, if we have what? R is equal to 170q minus 5q squared. This will be the letter which is this side.
Sorry, Mr. Collins. On this last equation here, dp over dq, can't it be simplified further?
No, because there are no like terms there. You can't add anything. It just ends here.
Oh, okay.
So here there's TR this side and there are Q's this side. So it will be the TR over the Q. Calculus is the easiest in this topic because it's just a simple rule. So there's an invisible one there. 1 times 170 is 170. Then here it will remain with the Q will drop out. So 170 Q becomes 170. 2Q becomes 2. 100Q becomes 100. Whatever Q is just that number. Then 5Q squared, when you differentiate this one, you're going to have 2 times 5. What do we get? 10. Then when you subtract 1 from there, it's the power 1. So I'm going to do 5 of them. I want each one of you in pairs, 2 of you to do them. A, B, C, D, and E. So y is equal to 6x to the power 4 plus 3x to the power 2 minus 5x plus 7. Then profit is equal to 2x to the power 3 minus 4x plus minus 10. And TR is equal to 14 minus 5Q3 plus 2Q. Then total cost is equal to 10 plus 5Q. And finally, utility is equal to 5x to the power 3, y to the power 7. So let's start the first team. Brenda, Elijah, Helena, then John, Lawrence, Mlenga, then Kosha, Mwase, then Mwenje, then we have Janet, Amwai, then Naomi, then finally Pamela and Sharon, in that order. So here, what do we get? To be the what?
In this one, we get the dy over dx. Yeah, that one to be 24x3 plus the 6 to the power. Yeah, plus 6 to the power x plus 5. Minus 5.
Correct. Sure. So he differentiated this by that is 24. He subtracted 1 there. Then 3x2 becomes 6x. Then 5x is just 5. What happens to 7?
To 7 because it has no x. That one disappeared.
It's a constant. It disappears. Correct. Next team.
Yes. Sure.
Next team. This is profit. Yes. Pi is got what?
Okay. D pi over dx. Which is equal to 6x squared equal to 6x squared.
What do we have here?
It's equal to 6x squared.
6x squared, correct?
Minus minus 4. That's it.
That's it, correct. Next pair.
Whose place is supposed to be?
dTR over dQ.
TR stands for what? Total revenue. When you differentiate it, the name becomes marginal revenue. Just becomes M on the T. Yes?
Is equal to negative 15Q squared.
Negative 15Q squared.
Plus 2.
Plus 2. Excellent. What happened to the 14? It dropped out.
It disappeared. Yeah.
Okay, next team. TC. D what? DTC over
DQ.
Mm-hmm.
I think there it's I'm just thinking, I think it's 5, just 5.
That's 5, yes. Our
Yes.
DTC becomes marginal cost, so we're just going to have a 5 because the 10 drops out and the 5Q becomes 5.
Yes.
The last pair. The last pair.
That's right. DU over D.
Yes.
So a 5x3 and y7. So U stands for utility. So we're going to have du over dx, the first one. The next one would be du over dy.
Oh, okay.
So there are 2 pairs. So du over dx is the marginal utility of x. So since we are only interested in the x, the y will remain as it is, as y7. So we're going to differentiate 5x3. What does 5x3 become?
It will be 15x squared.
Yes, 15 be 15x2, correct. Then when you differentiate du over dy this time, it will be called marginal utility of y. Our constant or our dummy will be x3. Just this part there, you remove it and you put it here. So we're going to remain with what? 5y7. When you differentiate 5y7, it is what? When you differentiate 5y7 will be what? 35y what?
6.
6. Excellent. Suppose we had 10x4 y2. So du over the x, our dummy, will be what? Our y2. So we're just differentiating 10x what? 10x4. So in differentiate 10x4, it becomes 40x what?
40x3.
Yes. Then if you go to du dy, this one will be our marginal utility of what? Of y. So we're just removing this. Our dummy is x4. So what are we going to remain with? 10y. 10y2, which will give us 20 what?
Just 20 to the power 1.
20y1. Okay, so 20y. Excellent. So this is important in the application. All right. So this will be important when we be applying. So we're going to learn how to now look at total revenue, marginal revenue, total cost, marginal cost. So at this point, I'll ask for any questions if there are any.